Okay, some more examples on discrete probability distributions, or discrete random variables, as they sometimes referred to, with a little twist at the end, which is called coding. Okay, so again, what I'll do is I'll do the example, I'll ask you to pause, and then you can do the now you try, and then I'll do that example as well. So biased four-sided dice, so bias means that they're going to have different values. I'm not sure how you would create a four-sided dice. Does that even work? Who knows? Anyway, so this dice, this weird dice, has faces numbered 1, 2, 3 and 4, and it's rolled and the number is recorded. The recorded number is modelled as a random variable x. The probability of x being equal to a value is k over the value. So let's write that out as a probability distribution. So the only values that can come out, we can't get anything other than 1, 2, 3 or 4, and the probability of getting 1 is going to be k over 1. The probability of getting a 2 is going to be k over 2, because it is k over the value. That is what the definition says here. K over 3 and k over 4. So if I can find what k is, then I can find the probability of each of those different things happening. So I know that k plus k over 2 plus k over 3 plus k over 4 equals 1. I could stick that into Solver in my calculator, but I think I'll do it the long way. So I'll multiply through by 12. So I've got 12k plus 6k plus 4k plus 3k equals 12. Just write times 12 there. Sorry, I'm running out of space here. I'm going to go up here. So that gives me 25k equals 12. So k equals 12 over 25. So what am I trying to work out now? So okay, so what I want to do now is to use this to give me the actual probabilities. I think I'll just kind of run out of space a little bit, so I'll do it down here. 2, 3, 4. So p of x being equal to x. So that one is going to be 12 over 25. That is going to be k over 2, so that's going to be 12 over 50. K over 3, that's going to be 12 over 25 times 3, that's 75. And that is going to be 12 over 100. So that's k over 4. So 12 over 25 divided by 4, 12 over 100. Okay, so we can now start answering the questions. I'll do them up here. So the probability of x being greater than 2 is 12 over 75 plus 12 over 100. So it's that one plus that one, which we can stick in our calculator and is equal, simplifies down to 7 over 25. The probability of x being between 1 and 4, not inclusive, so greater than 1, less than 4, so it's just those two there, isn't it, is 12 over 50 plus 12 over 75, which actually simplifies down to 2 over 5. Do that on the calculator, that's the easiest way of doing it. And 3, the probability of x being greater than 4, as we can only get 1, 2, 3 and 4, the answer to that is 0. Okay. Right. So then I'm given a little bit of a strange question. So I'm given a random variable y is equal to 4 minus the random variable x, and I want to find the probability that 2 times x plus y is greater than or equal to 7. So actually what I'm going to do here is I am going to write that out by substituting in this for the y there. So that is x plus 4. Sorry, I've written that wrong, haven't I? Sorry, I should write that like that. Sorry, equals that equals the probability of that being greater than or equal to 7. So that gives us x plus 4 is greater than or equal to 7, which equals the probability of x being greater than or equal to 3. So I'm just simplifying what's in the bracket there. Greater than or equal to 3 is going to be that plus that, so it is 12 over 75 plus 12 over 100. So basically I have rearranged this to get it in terms of x, which is what I have the probability distribution for, and that is 12 over 75, so I need to just whack that into my calculator, which I'll just do here. Sorry, I didn't work this one out separately, there's no point doing this. 12 over 75, whoops, plus 12 over 100, which equals 7 over 25. Actually, I could have just taken it from up there, couldn't I? Because they were the same thing. Greater than or equal to 3 is the same as greater than 2. Okay, so sorry for the slight muddles on that, but we got there in the end. Okay, so that's that. So what I'd like you to do now is to have a go at the now you try. I'll do the solutions at the end. So pause your video now. Okay, so hopefully you've had a go at those. So let's have a look at them. A bias spinner can land on any one of the numbers 1, 2, 3 and 4, and the number it lands on is recorded. The recorded number is modelled as a random variable. Given that, I think there's a missing P there, there is a typo. So the probability of that, of x being equal to x, is k times x. So let's write out the, actually this, okay, yeah. So I'm going to write out the different values that the variable can take, 1, 2, 3 and 4, x being equal to x, so that is k times x, so this time that is k, that is 2k, that is 3k, and that is 4k. So we know now that k plus 2k plus 3k plus 4k equals 1, so k equals 1 over 10. Okay, so that tells me I can now write out my probability distribution with the actual values in. So I've got 1 over 10, 2 over 10, 3 over 10, 4 over 10. It often helps not to simplify the questions in this case. Because we're working with the fractions, it makes it easier to add them up if we've got the same denominators, so I'm just going to leave them like that rather than simplify. So the probability of x being less than 2, so that is only that one there because it can't be 2, must be less than, so that is simply 1/10. Probability of x being between 1 and 4 is not inclusive, they're not equals 1 and not including 1 and 4, so it's just these two here, so that's 2 over 10 plus 3 over 10, so that is equal to half, 5 over 10. And then the probability of x being greater than 2 is that, and that can be 3 and 4, so 3 over 10 plus 4 over 10 equals 7 over 10. Okay. And then we get to the random variable part. So this time y is equal to 3x, and I'm told that the probability of 4x minus y is less than or equal to 2. So I'm going to substitute my y in there, which is 3x less than or equal to 2. So the probability of x being less than or equal to 2 is what I'm trying to work out. So now I can go to my probability distribution, and I can see that less than or equal to 2 is those two. So that is 1 over 10 plus 2 over 10, which equals 3 over 10. And that's the answer that you should have got. Okay, I hope that was helpful.